Example 1. Determine the force that water pressure exerts on the inclined side plate A, B, D, E of the storage tank and find its location measured from AB provided in the figure. Now our AB is at the very top, which is at the level of our free surface, right? And then we have our inclined plane A, B, D, E. Okay. So the first thing that we are going to do is assess first what type of fluid we have. And our fluid is a liquid, and the type of liquid would be water. So therefore, the property that we are going to use is the density of our water, which is equal to 1,000 kilogram per cubic meter. Okay, and if we can observe that that our inclined portion of our storage tank is a rectangle, right? With a height of 3 meters, this 3 meters, and its base is 1.5 meters. So our plate is, we can write it as plate is rectangular, is rectangular. Now, why is it important to assess what plate that is? It's because whenever we will find the value of our center of pressure in the y or x component of our center of pressure, we will be using the moment of inertia, right? Okay. Next would be our height, meaning the column of our fluid, which is 2.5 meters, right? 2.5. So height is 2.5 meters. But of course, the entire length of our rectangular plate, length, length of plate is equal to 3 meters. So therefore, if you want to measure for, okay, wait, we write our required, what is required is the resultant and its center of pressure, meaning where it acts, measured from AB. Okay, so for our solution, now in order for us to get the value of our F sub R, the formula would be gamma times H sub C times our area. Okay, now I have mentioned that the height of our column of fluid is 2.5 meters. So if we try to, if this is our plate, which is, let us have a side view. Okay, this is 3 meters, right? And this would be the column of our fluid, right? And that is equal to 2.5 meters. So therefore, our H sub C should be 1/2 of the total height of our column of fluid. And that is here, which is measured from above. That is 2.5 divided by 2, that is 1.25 meters. Okay, now we know that our gamma is equal to rho g, so let us rewrite this one as rho of H2O times the acceleration due to gravity times the center of where our resultant force acts at the centroid of our uh, plate times A. Okay, now this is equal to our Density is 1000. So we got 1 times 9.81, right? For our acceleration due to gravity, which has a unit of meter per second squared. And our h sub c is, like I said, is 1.25 measured from AB or from the free surface. That is 1.25 times our area. And now our area is the area of our plate. And since we have established already that our plate is rectangular, so its area is base times height. Now its base is the length of A to B, which is 1.5. This 1.5 times the height, which is 3 meters. So that is 1.5 times 3. So, but before that, let us have some dimensional analysis. 1000, our density has a unit of kilogram per cubic meter. Our 9.81 is meter per second squared. Okay, our 1.25 is in meter. Okay, and our area is in meter squared. This part here, kilogram meter per second squared becomes Newton. Meter cube, we have meter times meter squared, so it cancel out. So our remaining F sub R is equal to 1000 times 9.81 times 1.25 times 1.5 times 3, and that is equal to 55,181.25 Newton. So this is now our magnitude of our resultant. So now for its center of pressure, we have provided that y sub b, meaning the y component of our center of pressure, is equal to y sub c, which is the our centroid measured from the top. I mean, measured from the free surface of our plate, plus moment of inertia times y sub c times a. Now, since like I said, we have established that our plate is rectangular, then I believe I have uploaded in our Google Classroom the various formulas for centroids for various shapes. So you make use of that file, and provided in there is the moment of inertia for a rectangular plate, and that is, we know that x is equal to 1 over 12 base times a cube, meaning a cube is the height. Now, I believe in the text, in that reference, it uses 1 over 12 a b cube. Now, don't worry, these are just variables, so they can be interchanged. What we need to remember is that if we have our plate, and if we draw our coordinate system here, y, and this is our x, this part here will always be what is being raised to the cube. Okay, meaning, yeah, this portion is what is being raised to the third power. So let us say being raised to the third power, raised to the third power, and this one is raised to the power of 1. So if you let raised to the power of 3, so if you say this is your a and this is your b, then it becomes b times a cube. And if you say this is your b and this is your a, then that is a times b cube. Okay, this portion here, the y, is what is being raised to the power of 3. And substituting our values, y sub c, okay, since the length of our plate is 3 meters at the very center, at the centroid is 1.5 or 1/2 of 3 meters. So that is 1.5 plus I sub x would be 1 over 12 of our, again, the base that I will be using is 1.5, and what is being raised is 3. 3 cube divided by 1.5 times the area, and that is 1.5 times 3 times 1.5 times 3. So our y sub b is equal to 3 cube is 27 times 1.5. It's 40.5 divided by 12. That's 3.375 divided by quantity. 1.5 times 1.5 times 3 is 0.5 plus 1.5 is 2 meters. 2 meters from AB. Now, this is the y component of our centroid. Now, the x component is equal to 0 simply because of symmetry. Ay, symmetry. What's happening? Okay. Mm. So this is now our, so if you can observe here, this is our y sub p, and we don't have a value of our x sub p, the x component of our center of pressure, because na-jud siya sa tunga ang imuhang line of actions sa imuhang resultant force. That is example number 1.